Finally, part K, my favorite one. We want to set up an equation to calculate a time when its particle's instantaneous velocity is equal to its average velocity over the time interval 2 to 4. Well, we already know the work that we did in the previous problem, actually letter B, we found that the average velocity of this function, happens to be 2. So we're going to take that value of 2 and we're going to set it equal to the instantaneous velocity. So when is 2 equal to 6t squared minus 30t plus 36? Can't get rid of the 6 in this case because remember, in order for us to solve this, we need to make sure it's equal to 0. So I've got to subtract 2 from this bad boy right here. And now we're up to 34. Feel free to try to factor it. Isn't going to really work in this particular problem, but that doesn't mean it's not solvable. Remember, you have many tools in your toolbox in order to be able to solve quadratics. Probably the easiest one to use is your friend, the quadratic formula. So I want to find, again, on my interval between 0 and 5, where exactly is the instantaneous velocity equal to the average velocity. This, by the way, is the mean value theorem. So I'm going to go ahead and let the Pythagorean theorem, quadratic formula do all my work for it. So I get 30 plus or minus square, double check my own squares, 900 b squared minus 4 ac all over 2a. This gets me 30 plus or minus the square root of 84 divided by 12. Not hard to put in your calculator, not hard to calculate. And when we calculate this, I believe we get two values. When you take 30 plus the square root of 84 divided by 12, we get the values of 3.264, which is definitely in our interval, and we get 1.736. So in this particular problem, there's not one, but two places where our instantaneous rate of change is exactly equal to our average rate of change in that interval between 2 and 4.